Alright, hello YouTube, and welcome back to my little project here. I've actually got a prototype of the lighting that I'm going to be working on. Hi, cat. My cat just walked underneath my chair. So I've actually got the prototype that I was doing a little bit of testing off camera set up, so you'll notice that the lighting is a whole bunch brighter currently and a lot more even. There aren't as many sharp shadows. Which means that I'm on the right track for the style of lighting here. So, I'm basically going to show you what I'm building for the moment. This is only a temporary solution, and then we'll just go from there. I've already done some of the work off camera because it's a bit menial and kind of boring. So I've got my cobs here, and I've got the solder pads mostly all... Oh, look, a cat hair. Mostly all prepared, and I've got some of the wires that I need already prepared, but I've saved some so I can show you a little bit about what I'm doing and how I do it for this particular setup. So I'll start by preparing one of the cobs here. Now, each of these cobs has these little tiny copper pads. They might even be gold, but there are some manner of conductive material here. Plus and minus, which if you apply voltage across these, it's got them all, the circuits are all in parallel. So you just need to connect the pluses to the pluses and the minuses to the minuses, and they're all running in parallel. So what I'm going to do is, this is my flux paste. This is specifically for electronics. You don't want to use plumbing solder paste because it's acid bearing, and you don't want to use an acid bearing paste on electronics. So what I do is I just take a little dab of this stuff and put it on the pad. Oh, that's a little too much. There we go. And I'm just using a toothpick to do this. I'll just put a little dab, another little dab, just like so. Come on, get on there. There we go. I'll set that aside for a moment. And then grab my soldering iron here, which is turned up fairly high because these cobs have the aluminum core PCB here. So it is actually surprisingly difficult to get solder to stick to these. So there are two ways you can help yourself, actually manage to get solder to take on these. One is to use the flux. Two is to use lead-based solder. Everybody freaks out about lead-based solder. Oh, lead is poisonous and the fumes will kill you and yada 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 yada. Well, I guarantee most of the fumes that come from soldering is because of the flux in the core of the solder. Because if you watch, if I dab a little bit of flux onto my soldering iron there, it lets off a nice little puff of smoke. The same with my tinning compound here, which is basically just this actually is slightly acid bearing, and it's got lead-based solder and some other stuff in it, and it's used to clean gunk off of your soldering iron. So you put a little bit of that stuff onto the working surface of your soldering iron, and then you scrub it off in your sponge or whatever little thing you have for cleaning off the tip, and it makes your tip nice and clean. The other part that will make this a lot easier is a soldering iron tip that has a fairly high thermal capacity. I used to almost exclusively use these nice fine tip ones because they're nice and accurate. You can get the heat right where you want it and stuff, but they don't have a lot of thermal capacity in that you can't put a lot of heat in one place all at once because there's just the tiny tip. So I would have a heck of a time soldering onto an aluminum core PCB with that soldering iron tip. So from watching other channels, I've learned about this particular tip. This Big Clive specifically uses this tip, and it's, I think they call this a chisel tip. I'm not too sure, but it's basically just a round, flat tip, cut at an angle there, so it's got a really high heat, really high thermal capacity, and you can still get a fair bit of accuracy being as it's got that sharp tip. So what I'm going to do here is I'm going to lay a fair amount of solder onto the tip of the soldering iron. See, more smoke. There's no lead in that. That's just the flux core in the solder burning off. And then I'm just going to heat the PCB up a little bit and flow some solder onto those pads. The only disadvantage to this flux is that it is oops, just did that thing that I always advise people not to do, which is where you take the soldering iron away before you take the solder away, and your solder gets stuck to your surface. The only disadvantage to using this flux is that, of course, when it gets hot, it melts and it gets everywhere, and it's very sticky because it's basically tree sap, specifically pine tree sap, because apparently the resins in that help melted metals stick to other metals. So I'm sure the chemicals in it have been refined over the years. But that's basically what this is. This is pine sap, for the most part. Anyway, so the next part is all of the jumpers that I'll be needing to run between these cobs. Now, my initial thought when building these lights had been to use a mixture of the cold and warm white cobs, and it's seeming like I may not actually be able to pull that off because they have a fairly different brightness between them. So until I'm able to control them individually with LED drivers, I'm just going to go for a single color. Where did my wire strippers go? Wire strippers? Oh, there they are. So I'll be setting up a slightly different circuit. I'll cover that in a second here. So my next step here, and I already made most of the jumpers and tinned them up, but I'll show you what I do. I've got my nice high quality wire strippers here, and I'm just gonna nip the insulation using the 20 gauge preset groove, which cuts the insulation but not the wire. And then I'll show you a little trick that my dad taught me forever ago. And it's interesting, I don't see a lot of electronics techs do this kind of thing, but most of them will just yank the insulation straight off and then twist the wire with their fingers. But I found that, well, I was taught that you get a much more uniform twist on your wire if you twist off the insulation as you pull it off. And it makes a very uniform and extremely tight twist on the wire. I'm actually struggling with this a little bit because it's 22 gauge wire and the smallest groove on my wire cutters is 20 gauge, so I have to give it a little bit of a harder twist. But anyway, so you twist the insulation as you're pulling it off, and it gives the wire a really tight twist on it, which takes on a bunch of solder when you tin it, and makes a very nice strong connection there. So the next step, I probably overuse this solder or this flux a little bit, but I like to take just a little bit of a dab of the flux on the wires there, and then I'm just going to quickly tin these like so. The tinning is important because it really helps you connect the wires to whatever you're going to connect them to, and of course also adds a little bit of strength to the end. So there's that done. So the next step, well, I guess I'll show you the circuit that I'm going to be working on building for my lighting here, and then we'll move on. So, being as I don't have the components yet to build constant current driven circuits for my LED cobs, I'm just using a simple voltage divider circuit, which I talked about in the first video in this series. Now, the idea has gone through some refining since that first video, as I've been experimenting with the LEDs and methods to hook them up. So what I'm going to do is I'm going to have my plus 15 volts here, and it's going to come off here, and then I'm going to add a fuse into the circuit, just in the off chance that something goes horribly wrong. I won't blow up all of my cobs, so that's going to have a 4 amp fast blow fuse in there. And then that's going to come out, and that's going to go into a 3-position toggle switch. And that's this cute little thing here. Now, this switch has 3 positions. It's got off in the center, and when we get to that point, we'll double check that with a multimeter. But I'm assuming it's got off in the center, on the bottom, and then on the top. And basically what that does is you put whatever signal you want coming in on the center pole, and then when you click it up, it's going to come out of that pole, and when you click it down, it's going to come out of that pole. And like I said, I'll test that with a multimeter later to make sure. But that's how that situation works. And that's going to be basically a quick and dirty brightness control. So that's going to come off, and it's got the 2 poles here. That pole is going to come off onto the first of 2 current limiting resistors, and then the other pole is going to be the second current limiting resistor, like so. So basically I can go click high brightness, click low brightness, and then actually I might even refine the circuit further now that I'm thinking about it. But this is what my initial thoughts were, so we'll go from there. And then that's gonna just common terminals on the end there, and then that is going to come out, and then we're going to go into a 2-position toggle switch. Now this works along the same lines, except there's only on and on. So with this one again, I'm assuming the signal comes into the center pole here, but instead of having an off position, it just switches between the two poles. So if you've got it down, it'll come through this way, and if you've got it up, it'll come through this way. So here's that switch, and that's going to come out, and that's going to go into our LEDs. Oops, I was drawing another resistor into our... Oh. Imagine that I drew a nice LED right there. We'll just do it nicely here and kind of do that. So there's our LEDs there, and that's actually, this is going to be the array of 6 of these in parallel. And then those will just common terminal at the end there, and then that'll come out and return to the negative side of the power supply. Now the refinement I just had in my head was to actually put the 2-position toggle here for the brightness of the resistors, and the 3-position toggle here for the selection of the lights. It doesn't really make any difference, but if I do it with just the 2-position switch here, I'll be able to flip between brightnesses without actually turning power off to the LEDs between. It'll just go bright or dim. So I'm probably going to do it that way instead, but that's going to come later. For now, we're just building some of the hardware for the circuit. We're building the circuit for these cobs first. So we're going to get going on that. Now, these sizes of wires I chose are specifically for the width of the shelf that I'm actually mounting these to, which I've actually got my iPad sitting on and pointing down. And we'll just start to put these together. Now, the power supply that I'm actually using to power the LEDs, even now, so I have to be a little gentle here because the circuit setup over there is very improvised at the moment. But I've got a stripe on one wire and then solid on the other wire. I'm not too sure if the camera's going to pick that up too well, but as we discovered in the last video, that stripe is the positive terminal of that wire. So we're going to keep with that convention with these wires, putting the stripe on the positive terminal. So this is going to be very simple and quick. You just dab the soldering iron against the wire and the blob of solder that we previously applied to the board, and you'll notice that it takes a far less effort to connect the wire that way. Of course, I've covered up the polarity indicators with charred rosin, or charred flux, which is the other disadvantage to the flux. It does, like I said, it gets everywhere, so it's a little messy. We're just gonna keep working on this. Fly decided it wanted to be part of the video. Not too sure if it's going to show up on camera, but apologize for the distraction if it does. So the first part of this is to have 3 connected with these short wires. I'm just going to spread that open a little bit further there. Do a little. Remember to do the work on camera, Chris. Here we go. There we go. There's that one. There's that one. So we want 3 connected with these short wires. Oops. Bollocks. There we go. Like that. Oh, that's not even remotely properly. It's a very cold solder joint there. Let's get that done properly. There we go. Much better. So there's one side of the lighting. Just 3 of these cobs connected with the short wires. And then that's going to basically go on the underside of one side of the shelf. Then we're going to take this longer wire and run it back to another set of 3 of these and put that on the back of the shelf. So I have three LEDs and then 3 LEDs. So we'll just go into time lapse real quick while I finish those 3, and we'll go from there. So see you in a minute when I get back from time lapse. Alright, and we're back. I'm glad I went time-lapse on that because I was struggling with one of those cobs a little, trying to get it to solder nicely. So here we have the entire string of LEDs. Trying to lay them out nicely here so they're all visible. Because now we're going to quickly test them. Now there is a rather strong disadvantage to setting the circuit up in this manner, and that is that each of these cobs probably has a slightly different current draw, which means that setting them up in parallel like I am, there's going to be a bit of a variation in brightness between each cob. And unfortunately that is unavoidable when you're setting up the circuit like this, but there's not much I can do about it. I could set them up in series with their own current limiting resistor, but then instead of spending $28 on a 12-volt power supply, I would need to spend nearly $100 on a 70-volt power supply. So it's kind of a bit of a give and take there. The weird thing is that when you're doing the entire string at 12 volts, you need a 3 amp power supply. But if I was doing the whole string at 70 volts, I would only need a 500 milliamp power supply. So I may look into that for a later version of this circuit. Sorry, headphone users. I was trying to kill a fly there. I don't think I got him. So what oops, I should probably tin this first. What I'm doing here, I should have done this earlier, is I'm just setting up a quick jumper. Because I need a place in which I can connect to temporarily. So I'm just going to do this up real quick. I should have done this earlier. So there we go. There's that. And then I'm just going to go into my drawer here. And I guess I'll just temporarily use this one. So I'm just going to grab one of my great big power resistors here. When I was demonstrating for the math, or when I was demonstrating the math for these in my other video, I actually did the math incorrectly and discovered when I was working off camera that the 10-watt resistors that I initially purchased, these little guys, weren't going to be sufficient, and I had them all at the wrong values. So now I've got a bunch of 10-watt resistors that I have absolutely no idea what I'm going to do with. Maybe I'll make an oil diffuser with them, which you just put them on the bottom of a bowl and then you run sufficient current through them to make them hot. So I'm just going to grab this great big 25-watt resistor here, and that's a little excessive there. Let's wipe some of that off. I'm just going to tin the one end here and connect it to the positive terminal of the LEDs here. There we go. And that's why you tin things, because all I had to do to get those two to connect was to tap them with the soldering iron, which melts the solder that's already on both terminals and fuses them together. That's a nice, quick and clean way to set that up. Now, I have here on my lap a little power supply that I borrowed from school. So I'm going to set that to 15 volts real quick. I'm going to plug it in over there. Try not to get the cord into the flux. Let's put it over here. That fly is really starting to annoy me. Alright, we're going to connect the terminals here. So, let's see, what's the positive terminal. Good rule of thumb when you're connecting a power supply to anything is always start with the negative terminal and then the positive terminal. Now, because of the way this power supply works, I'm actually going to turn it on and let it get powered up before I connect it. There can be a fairly strong initial transient surge when you turn these little cheap power supplies on, and I don't want to put that through the LEDs, so we're just going to connect that. I'm not too sure if you can see on the camera, but there's a substantial brightness difference between these three and these three, which is a little dismaying. And I can see a substantial amount of flicker in that, which means that this little power supply here doesn't have a very good smoothing capacitor in it, and on the iPad that I use for filming, it's probably even worse. So that's that. I'm a little dismayed at the rather strong difference in brightness between those two cobs, but I guess there's nothing for that until I actually am able to control the current to each one individually. So I'm going to leave this video here. In the next video, we'll finish construction of the primary circuit. I'm going to play around off camera with my prototypes to figure out what kind of brightness I want to establish for the circuits, and we will go from there. So thank you very much for watching. Give a like, share, or a subscribe if you enjoyed it. Share it with your friends. Also, check out my Patreon. I've got a link to that in the description below. We'll see you in the next video.